let's do these matrix problems. These are also from blind curated 75. So let's do this. This is basically related to just the matrices. So we'll loop over the matrix and see how it works. Let's make it all to Java. Okay. Rotate image. This rotate image problem, I already have a video on it. It was long back. I will do the same. Basically, the idea on rotate image is to do the transpose and then do the reflection, that is reverse. So if you look at the basic geometry, right, so how do we, if we have two xy plane and if we want to just rotate it, what we do is we first transpose the image and then that xy goes to yx, I mean the other half of the plane, right, to minus xy. And so to do that, just to transpose from xy, first we'll make yx and then move it to minus xy plane. That's how the image will be rotated. So is the case in matrix also. So what we will do in this matrix is, so let's first just do the transpose, that is 4 will go up here, 2 will come here, 7 will go up here, 3 will come here. So that way what we will have is, okay, 7, 1 and 4 all in one place. Similarly, if we put 8 and 6, then 6 comes here, that is 8, 5, 2 will be here, 2 will come here, so 8 will come here, so this will have 8, 5, 2, and then we'll simply reverse it to get 7, 4, 1 and this, right? So let's do that. So what we do is, for every element, yeah, so from I equals to 0 till the whole length, what we'll do is we'll simply j equals to, so how do we move it? We can move it from I, right? So if it is at 0, then it should be at I. It can start from any position, so I think that's fine. But I plus 1, basically we simply want to move this value here, so I plus 1 to j less than matrix 0 dot length j plus plus. If we do this, what we'll see is, okay, let's just put temp is equals to matrix ij, right, matrix ij, then matrix ij, so 0 1 will be 0 1, which is 2, will be 1 0, so it has to come here, right? So matrix j I and matrix j I will be this temp, right? So what we did till now is we simply did a transpose. So if we want to look at the output, we can, since this is a void, let's just run it. We'll see the transposed value, right? If you see this, 147 is all in one place, 258 is all in one place, 369 is all in one place. Let's try this. This is a 4 by 4 matrix. If you see this, we have 5, 15, 13, 2, 5, 14, 3, 4, 1, 12, 6, 8, 9, 16, 17. So everything is there. Now what we'll do is we'll simply reverse it. So to do the reverse, for every so from here to here, we'll simply rotate this array, right? So for in j equals to 0 to 0 is the matrix matrix dot length j plus plus. What we'll do is temp is equals to our first variable, which is matrix of I and j, right? So the last variable will be a matrix of, at this row, matrix 0 dot length minus j minus 1, the last value. This will be how much will, so matrix I j will be this, right? And then this one will be 10, right? So if we do this, so what is the problem here? Matrix I and j, oh, need to go to j. Okay, it's a wrong answer. So let's see what happened here. So we had the transposition right, but our, oh, so yeah, what we're doing is we don't want to rotate all, right? We can just go till the half of it when we are rotating. So yeah, because if 15 goes here and if you are still rotating it, it comes to its original place. We don't want to do that. Let's see. Cool. Rotating image is done. Then spiral matrix. Given a matrix of m times n elements, m rows and n columns, return all elements of the matrix in spiral order. Okay, so let's just say our list of result is array list, and we simply want to return this result. So since we want to print all these numbers, right, a matrix of m into n, so what we need to do is at first, okay, for int I equals to 0 till I less than matrix dot length I plus plus, what we need to do is we need to add this, so dot add matrix I 0 I, so 1 2 3 is added, right? Similarly, for int I equals to 0 till I less than matrix 0 dot length I minus I plus plus again. So what we'll do is so this one will be 0 dot length, so from here till here, and then this one will go from, okay, so once it goes down, the next time it has to come from here, right? So, and how do we decrease it? So what we, let's introduce some other variable. Okay, int left, so we start from 0 and we go till the right point, which is right, and this right is equals to matrix 0 dot length, so that we can go from left till right, let's do -1, we can go till the right, and so also we need to go from top to bottom, so top is at 0th position and bottom is at matrix dot length, right? Yeah, 3. So now what we do is, okay, but how many times are we going to do? So once it goes from here, it has to come down, comes left, comes right, and then it needs to loop over again. With all these left will be increased here, so how many times it has to do this? Okay, so it has to do this. Let's say our int breadth. So breadth is matrix dot length 0 and height is matrix dot length, right? So for we need to do this while result dot size. So till the result size is less than the this breadth times height, right? Breadth times height. So this will give, since there are 9 numbers, the result size will be 9 because we need to include all, right? So for all this size, what we'll do is what we'll do is from left to right we add the numbers 1 2 3 0 1 0 2 0 3, and then from top to bottom, right? So this 0 is basically our left position, right? So wherever we are, so from left till I, because next time it has to go from 5, so left I, and so this one has to come from top to bottom, right? So top till bottom, uh, and it has to increase. So that means, okay, result dot add. So what we need to add here is, so this element's position, which is at right, so right position, which is at 3, and we sequentially increase, that is I. So we need to go from, this 3 is already included here, right? So we don't want to include 3, so let's go from 1 so to bottom. Bottom is 9. Since bottom is matrix dot length, let's just put it -1, so we can go till the bottom, right? So we included 9 also. Now it has to come from 8 till 7, right? So to come from 8 till 7, what we need to do is we need to come from right to left, right? So we are at right is already here, so we need to come right -1, right -1 till left with a decrement, yeah, of course, with a decrement, and once we decrease this, result dot add, what we need to add now is, this is the bottom part, so on the bottom what we're doing is bottom I, right? Yeah, that's fine. And finally, when we are moving top, how we are going is we are going from bottom -1 till top. So bottom -1, which is at 4, till our top is there, so top +1, right? Top is at 0, that's why. So result dot add matrix add. So this is our leftmost part, so I at left, right? Because 1 0 2 0 3 1 0 0 1 0 2 0, so left is at 0. Okay. And now what we need to do is, when it goes to the inner circle, we need to repeat the same thing. So at this point, left will increase by 1, left increases by 1, rightmost part decreases by 1, and then top part increases by 1 and the bottom part decreases by 1, right? I think this would print this spiral matrix. Okay, result of that. Okay. Okay, array index out of bound -1. Why is it -1? Is bottom matrix dot length -1? So we need to start from this. On the left side, we need to go to oh, greater than or equals to top plus 1. Even here, whenever we are going from right to left, right is more, so we need to do like this. Okay. We are printing 1, 2, 3. Then it came 1, 2, 3. What we need is 6, 9. Okay. So while going from top to bottom, okay, while going from top to bottom, what we need to do is we need to be at I, but at right position, right? Because this is the right we are using from top to bottom on the rightmost edge. Okay, this should be fine. Let's see. Okay, wrong answer. Basically here one more element came in, the loop kept on going, so that means let's put this, so breadth and height. So for every, so one this element ran again, right? So and size less than this, and result size, result size. So what we are doing now is, since we need to loop only till the 4 times 3 here, right? 12 times, but it went past 12, so we need to check before adding the number. Let's just see if the size already matched. I mean, there are 12 elements in the list already. Okay, runtime error, index 0. Okay, if matrix dot length equals to 0, for empty it is throwing the error, or let's just say matrix, either way, dot length equals to 0, we'll simply return result. Okay, cool. Set matrix as 0 given m into n. If an element is 0, set its entire row and column to 0, do it in place. A straightforward solution using probably a bad idea, simply n plus n space, but still not the best. Could you devise a constant space solution? Yeah. So this problem was also, I think, listed in Cracking the Coding Interview book. I'd seen this problem in that book long back. So what the idea is to use an external array which will say, okay, what rows have zeros in it, and just by checking that we'll simply uh, zero all these rows and columns, right? So for this problem we have 0 here. We assign 0 to all its row elements and column elements. um, yeah, so the basic plan is, if we have a 0 here, what we can do is we can say that okay, its topmost row is 0, right, and its leftmost 0th index is also 0. If any 0 is found, then on the next loop what we can do is, okay, if 0 is found, let's just put all this 0, and if this 0 is found, all this 0. uh, but the problem is on this situation, like if this topmost element already has a 0, then what do? We can't. Yeah, we can go on the bottom. Yeah, and then we can also go on the right. So okay, let's see. So what we'll do is, basically if there is a 0, we'll just assign to a row and column in the 0th index, so that later on when we, okay, if we simply assign it here, our idea is not to loop through it and then simply make it a 0, this whole row, right? So that is what we want to prevent, because this 0 was introduced here because of this element I11. So what we'll do, uh, for every int I equals 0 to I less than matrix dot length I plus plus. How about we keep a variable which will say, okay, does this row has a 0 or not, right? So we can simply introduce a variable saying, okay, int row 0, row has a 0, or int column 0, 0. There is a special situation like this where both row and columns are 0, right? In this situation, we'll have to make everything 0. Yeah. Okay, so what we'll do here is, for int 0 till j less than matrix 0 j plus plus, then what we'll do, if this matrix I and j is 0, right, on whenever we are looping, and if I equals to 0, that means on the first part, if the 0 is found, then that means row is 0, row has a 0, right? Similarly, if j equals to 0, on z0, if it is found that the element is 0, then column, well, basically this one is the column, so we can simply say column 0, and this one is, oh sorry, I was right. So column 0 is true, because yeah, this we are looping through I0. So if I on any of this is 0 1 0 2 or 0 1 0 2, anyways, okay, on this row, okay, we have one element 0, and on this column we have a 0. That's fine, we'll think about it. And then matrix I, let's just put on this first row and first column the 0. So matrix of on this 0 z. So if the element is found 0 here, so what we need to do is, this is, we'll simply put z0, this one as 0. If let's say this one was a 0, then this, let's put this as 0 and this as 0. That means 0 and j, right, which is a third, is true, and matrix I 0 is a 1 0 will also be, let's just make it 0 because it can't be true. So column 0, let's just make it boolean so that we'll know. Okay, so till now what we did is, we figured out all, wherever the 0 is, and we simply kept it here. Now what we can do is, if the 0 is found here, right, so for every 0 till I less than matrix dot length I plus plus, so whenever we are going through here, so if matrix, no matter if, even if this has a 0 or if this has a 0, the whole rows will be 0. So let's just make the whole row 0. So if matrix I 0 equals to 0, right, then what we can do is, if this I 0 is 0, then for in j equals to 0 till j less than matrix 0 dot length, so every element on this row will make it 0. So matrix of I and j, for this constant I and this j, we are simply making it 0. The whole row will be 0. Similarly for column, what we can do is, let's just copy this, for matrix 0 dot length, if 0 j, if any of these row has a column index 0, I mean 0 on the top, then what we can do is ji matrix. Okay, so all these column will be 0 now, so j goes from till the matrix at length from this index, right. Now what we did is, okay, so this 0 came up here. Whenever we found this 0, we made all these elements 0, and what we did is, whenever we are now what we need to know is, if this first index had a 0, then this whole column will be 0, right? So that means for, okay, if row is 0, if the whole row has a 0, right, that means what happens is, we'll simply make, okay, for int I equals to 0 till I less than matrix 0 dot length I plus plus. So since this row has a 0, we'll simply make the whole elements in this row 0. So matrix 0 I, so every element in this row will be 0. Similarly, if column is 0, then we'll make all these columns 0. Right. Let's see. Might not have been initialized. Okay, let's check this matrix. So now what happened is, everything became 0 because okay, in this situation it failed. Why did it fail? Let's see. So we had this as 0, and what we did is, okay, we assigned this 0 here, and whenever we found that matrix I0 is 0, we simply say that okay, all these elements should be 0 and all these elements should be 0. What happened? Why is 4 5 gone? What impacts it basically? So our row has a 0. Okay, since this belongs to both, right, row and column, let's see what's happening. Oops, okay. Thought my recording was gone. Let's just check this. Okay, we have 0 0. Our output is this. Now if we simply remove this, what happens is oh, you see what happened? Okay, I think I got it. So what was happening is whenever we are setting this values to 0, we are making this whole column 0, right? So what we need to do is let's not go from 0, let's just do from 1, so that every elements after it won't be set to 0, right? So what was happening, this 0, even the loop here was making all this 0, so that the next time here we are simply making all this 0 again. So if we simply go from 1, will not set anything, then I think we should be good. Let's see this test case. Yeah, we are good on the first one. Okay, let's see. Okay, cool. That's it, guys. Now we have the last, which is the word search. This word search is given a 2D board and a word. Okay, we have a board and we need to find a word. And if this word is present, this is a famous problem actually. The board and word consist of lowercase and uppercase English letter. Okay, so let's do this. So what we want to do is, so we want to look through all these elements and we have this. So we'll simply use a DFS. This is a float filling algorithm, similar to that. So once we find this, we'll recursively check all these elements in overall board, and if it is found, we'll return true, else false, right? So this is kind of a template problem. I mean, this is a generic problem. So just learn the pattern, how to solve these kind of problems, then I think this kind of template will help solving a lot of other problems. So this is one of them. This has a kind of template which I'm going to write. So what we'll do here is, okay, we'll look through all these elements. Board plus plus 3. So what we'll do, is we'll simply search all this in this board. What we'll search with is we'll search on word. We have I, J, and our I, J, right? So this is how we will search. So let's say, so if the search, if in the board whenever we do a DFS search, let me rename it DFS search. Then board string word int row and column, and then what we need to pass is, since we have a word and we are checking its character, I want to pass the index also. So int index, right? And then we'll simply look through the board. So there are first patterns. I'll simply comment it out. First, check validity of the board, like if this row is less than 0 or column is less than 0. So right now you don't see why I'm doing less than 0, because this always starts from 0, but you'll see if you are not aware of this. Row dot if row is greater than or equals to row dot length, or column is greater than or equals to board 0 dot length, right? If such situation arise during our recursion, then, and if also, or if so these are all valid. So what we need to do is we also need a boolean array of visited nodes, which is boolean array of board name and board 0 dot length, right? And then we'll pass board here also, visited. So visited, or if this visited, if this particular place, if this is already visited, then we will simply return row column. If this is not visited, and if board at this row and column is not equals to our word char at, so since we are looking through this, and if this word doesn't match with our element, that is board dot char at, our index, then we will simply return false, right, in all this scenario. Now our true condition will be like, if this index is greater than or equals to word dot length, right, then we will simply say okay, return true condition, right? And then what we'll do is, okay, visit path, visit, right? So visit means visited, this row and this column is now visited, oh, not visited but true. So what we need to do is, since our we also need to on visit this path after a certain on visit this path, the same row and column when the search is made and if it is not found. So what I mean by that is, let's say we start from A, and ABC is A, B, C, C is our character, and if we go from, no, A, B, F, C is our character, then if we are going like this, A, B, F, somehow the F was here also, and let's say there was no C, somehow, I mean, if we visit this path, and if we denote it as visited, but this might be the solution, let's say if we want ASFCC, but our, let's say the B was here also. If we want ABC and ABFCC, in that case, if I mean ABFCC, if we want ABFCC, then whenever we are going, the B is found in both this index. Let's suppose this has B, so it goes, and there is a C. We might say that okay, this value is now visited, so let's not so whenever we go here, we might just return it saying okay, this word was already visited, return false. We don't want to do that, so we will simply say okay, we don't want to visit this path on the next recursive path, right? So we'll simply, that's why we are doing on visit. Here we are visiting it, and here we are doing on visiting. If you have a problem with this, just comment it out in the comment section, and I will be happy to help. Sorry. So the problem like this will be float fill, number of island problems, right? All those kind of problems where you need to just search through all the loops and go through all the directions. Yeah. So now what we do is, okay, this validity is found. Now result, right? So what we'll do, okay, return result, or boolean result will be, so where do we search now? Okay, at first we found A is found. Now we need to search B, right, in the same DFS search. So what we'll do, DFS search this board for this word. In row we can go either right into all the adjacent cells, right? So that's why row plus 1, we can go one row further, comma column. I mean, at once we can only move 1 point, so that's why we can't move diagonal to increase row and column. We just have to go 1, that's why row plus 1 column, and then we have index. Now since the first index is already found and we are searching for B, so we'll increase the index by plus 1, and the visited will be the same visited node, visited, right? This, or we can search, and this is going to the right. Now we can also go to left, right? I mean, if we were here and CBA was the answer, we need to go left. That's why, see, if we are going too much left, the row can be less than 0. That's why we need to say okay, this is false also. This, or so let me just copy all the directions that we can visit. So based on the shape and size of your path, you can simply modify this. So we are going on the row left and right, and we are going top and down, plus 1 and minus 1, right? Let's see. Okay, there is expected, yeah, semicolon is expected. See return statement. So if this search is valid, then we can simply return true, else we can simply return false. Sorry. Yeah, I think this should be good. Let's see. Accepted. Okay, cool. Thank you guys. It was a long video, but thanks. Good night. It's 1:16 again.